started. Okay, all good. Okay, so today what we're going to learn is, as we already know, last week we learned something on Numpy. So the same thing will be continuing. I think we got a couple of examples on Numpy, and then we'll move to Pandas. So it's been more than 3 weeks, I think. We learned Numpy, fair bit of examples on Numpy, numerical Python. So mostly on the arrays and dealing with indexes, searching the elements in the Numpy, and also say like searching the multiple values and sorting the arrays. And last week we also talked about these things: 2D arrays, filter, Numpy filter arrays, yeah, how you're going to filter the arrays using the Boolean variables and all, Boolean values. So, and what are the other examples? Yeah, filtering. So there were two other examples which we left in the last week, and the same thing will continue, and then we'll push it to Pandas. So week 9. So what we're going to learn in week 9 is something, few more examples on Numpy. Okay, little bit for 4 to 5 examples on Numpy, and then Pandas. The pandas are related to the data frames and files, etc. So this is what we'll be learning. So let's pick up one example, like creating a filter array that will return only even elements from the original array. Like if we look at this example, let me run this, what it is trying to do. It's giving some example like in false, true, false, true, false, true, false. But what it is actually doing it, why it is saying in false and true, the reason behind this, we got the list of array elements like in 1, 2, 3, 4, 5, 6, 7 array elements. And what we are trying to do in the next step is we got ARR equals to np.array array elements, but here filter underscore array, the blank empty list. So what we're going to feed in this blank empty list is with the true false details. That means assume like when you're dividing the element with 2, if it is 0, then true. If it is 1, right, then false. So it's like 1 divided by 2. Okay, so you can't make it as 0. That means it goes to false. Okay, and 2 divided by 2, 2 by 2 will be 0, absolutely 0. So when it is 2 by 2 will be 0, then add the value as like an, what we're trying is filter array dot append true. That means true will be here. First time it is 1, 1 by 2 will be, can't be as 0. That's the reason we got false. Second time 2 by 2, okay, it will become definitely 0, the remainder. So that's the reason we have true. And coming to the 3 by 2 will get one remainder at least. So that's the reason we're picking as false. So here what we're trying to do here is divide each element by 2, and if the remainder is 0, then push the value into the array list, empty array list as true. If the remainder is 1, then push value as false. So that's the reason 1 false, then true, okay, then false, then true, then false, then true, and then false. The same thing. That means we need to make sure that we divide by 2 and remainder should be 0 to get true. If it is remainder is 1, we'll get false. So if the elements is completely divisible by 2, set the value to true, otherwise false. This is what we're trying to do. So go through each element in the array. So that's the reason we're giving a for loop for element in the array. So which array? This array. So for element in array, if the element is completely divisible, if element is divisible by 2 and it is 0, and then append means you add the value to the filter array, blank array, and that is true, else false. Okay, and at the end of the day, what it is trying to do is the loop will continue for 1 to 7, And once it is completed and it appended all the values to the empty array, empty list. So what we're trying to do here, new array equals to array of filter array. Okay. So what we're trying to do here is we are trying to print the values from the filter array, right? And also print new array. Print new array will be like a 246. Why do we get 246? In the sense we got only the true values, 2, 4, 6. Those are the values, new array. Okay. So what we are capturing over here is we are capturing only the true values. So I'll put a comment over here. Capture only the true values. So in this case, that's the reason when we say new array equals to array of a filter array. So it is only capture the true values in this case, right? So, and that's the reason it beings like a, when you say new array, it's a 246. So in this format, when you talk about the list, filter array list, it brings everything. It brings everything. So 1, 2, 3, 4, 5, 6, 7. We get 7 elements here. 1, 2, 3, 4, 5, 6, 7. So all the list elements will be brought up here. Let me zoom it. I think if it is okay, I think it should be clear now, right? Let me see. Yeah, yeah, that's right. So here, what we have done here is we just push the values into the filter array and displaying, and then we're giving only the cases where only true. So 2 divided by 2 will be 0, 4 divided by 2 will be, so remainder, especially, we won't get any remainder. So 2 to the 4 will be, again, the remainder will be 0, 2 3 6, again, the remainder will be 0. So that's the reason 2, 4, 6, we are pushing it. So what we are trying to do is create a filter rate that will return only even elements from the original array. So what we are trying to do, even elements in the sense, to get the even elements, 2, 4, 6, we're trying to say percentage by 2 equals to 0. And what will happen if I give to 1, then you'll get the odd elements, like where the remainder is 1, like 1 and 3 and 5 and 7, the remainders will be 1. Those will be printed. So at the moment, we want only the even elements. So that's what we try to bring it up. So let me also put this as a comment. So it will be visible. So one more example. Okay, let me save this. So creating filter directory from array. So what will happen here is the above example is quite a common task in Numpy. That is saying is common task. Why am I saying? And Numpy provides a nice way to tackle it. The common task in the sense we are trying to capture the even number, even values. That's why it is saying common task. We can directly substitute the array instead of iterable variables. We'll see what it is trying to do. So let me read through again. We can directly substitute the array instead of the iterable variable in our condition, and it will work just as we expect it to it. So for example, let's take an example to understand. Okay. So create a filter array that will return only values higher than 42. So that is what we're trying to see. Okay, let's see how it is going to filter the array greater than 42. So greater than 42 means here 41 and 42, and it's like 42 equals 42 and 41 is less than. So how many values are greater than 42? They're 43 and 44. So how we are going to do that? Import numpy as np. That's a common line which we usually use for the numpy. So array equals to np dot array 41, 42, 43, 44. They are the values which we have defined. And what we are saying is filter array equals to array greater than 42. So this is a condition which we are defining, saying that if filter the arrays greater than 42, so we're giving like in condition ARR greater than 42. That means whatever the elements, it will be 41. first element. 41 greater than 42? No. Then 42. 42 greater than 42? No. Okay. Then again 43. 43 greater than 42? Yes. Then what it will do is, in the first instance, the same format what we have learned over here, like a true or false. So here also what we are trying to do here is, we are trying to create filter array equals to array greater than 42. Then what we are trying to do here is, so once we have these elements, right? So uh, we can have this session here also, like we can have like, if we have it here, okay, and if it have it here, so slightly I'm pushing it upwards. So the same, the case will be the same, right? So yeah, this one only. So what I've done is import numpy as np. We are giving the line for the import library. So array equals to np dot array, and what I'm trying to do, filter array equals to array greater than 42. When I say print filter array, so what should it print? So here what I'm saying is it greater than 42? That means you're trying yes or no, right? If it is greater than, say true. If it is not meeting the condition, say false. So Python will automatically pick the values false, false, true, true. The reason behind is 41 greater than 42, false. 42 greater than 42, false. Then again 43 greater than 42, true. And 44 greater than 42, true. So these values are being populated over here based on this condition. Array ARR greater than 42 means array greater than 42. So, and again, I'm printing the values, that too in the Boolean format. Why? Because you are picking up on checking the condition. So that's the reason it will automatically feed the values into the filter array with like a true, false, like and false, false, true, true. So next thing what we're doing here is new array equals to array of out of this filter array. That means this condition, what it is trying to do is, when we say print array, so you just give me the values which are where the condition has been met. So what I'm trying to do here is, check if the condition has been met, right? Like ARR greater than 42, and then print the values. So this is what we're trying to check here. So what I'm saying is, whatever the condition we have checked here, okay. So check if the condition has been met. That's what we did here, and then print the values, right? So new array equals to, when I say array of this, we are picking up the values related to the filter array and printing it. So these 43 and 41, oh sorry, 43 and 44 coming out of this print statement. So uh, let me comment this statement. Okay, what will happen if I comment this? See, what I got it here, I did comment it as print of filter array, and what I got is only 43 and 44. The reason behind is, so only this particular print statement has been executed, and that too, it has the values 43 and 44. Why? Because only these two values does meet the condition, like, and they're above 42. So that's the reason I commented. And if I uncomment it, right? If I uncomment it, I get the values false, false, true, true. So this is just to understand that how we are going to filter the values in an array, like creating a filter array that will return only values higher than 42. And also we're giving whether the values are being met or not. So it's one of the good example next time when we try to filter out, like, if there are any students in a college where we need to create a program to find out how many students have passed the exams and how many students are failed, and based on that we can skip the people who failed, and we can give the list only who have passed. So we can apply this logic. In that case, we can read the list and we can say, okay, give me only the list of past candidates. Then immediately it will filter out and it will give the example like in data. So let's pick up one more example. Create a filter array that will return only even numbers from the original array. So again, this is also the same kind what you have learned, but this time 2, 4, 6. So what's the difference in this case? So filter array and new array, I think it's all almost the same thing, but the only thing is that uh, instead of using for loop and if then else condition and everything, instead of going through so many for loops and if then else condition, so this time we are going into simple manner. We are not going to for loop, not if then else condition, very simple format, just in 2 lines. Okay, just in 2 lines we are trying to check import numpy as np. We are reading the values like an providing the values 1 2 3 4 5 6 7 as np dot array. This is what the condition is. So what we do here is when filter array equals to array percentage to double equals to, when I say double equals to in the sense the remainder. So 1 percentage to 1 divided by 2, if the remainder is 0, if it is 0, then true. If 1 percentage 2 doesn't equals to 0, the remainder won't be 0, so false. 2 percentage 2, the remainder is 0, yes, true. The same case 3 4 5 6 7, so 1 will be false, 2 will be true, 3 will be false, fourth one will be true, 5 will be false, 6 will be true, 7 will be false. So once these conditions are been met, so what we're trying to do here is we are just printing the values. So I can push the line, this print statement here also, the same case what I've done earlier, right? If I run this, so here what I'm doing is here trying to print all the values like false, true, false, true. Why? Because this condition, based on this condition, we can give only false and true only. We're not going to print the values. And the next line, what we're trying to do here is we are trying to pass the values which are being met with this condition. New array equals to error of filter array. So 2 4 6 does meet the condition with remainder 0. That's the reason you're printing 2 4 6. So this example is similar to the one which you have learned over here, like in creating a filter array with will return only even elements, creating a filter array that will return only even elements from the original array. But here we have checked with for loop and if then else, like in 4 to 5 lines. But here we are learning it with what we're running is just with the 2 lines, like in filter array and printing the values. That's what we're trying to do. So that is what with NumPy. So if you have any doubts, I will pause for 30 seconds and let me know if you got any doubts in NumPy. Okay. Okay. So today what we'll be learning is mostly pandas. So pandas is again one more Python library relevant to NumPy. Okay, same as numerical Python, but pandas related to the data, like you got an Excel sheet and you got an uh, text file, something like that, and you got a CSV file, you got a JSON file. So we deal with the files, exclusively with files, and reading the files and writing the files and cleaning the data inside whatever present in it. So today what I will be covering is related to the Pandas series. We call it Pandas series and Pandas data frame. And we pick up the files from the CSV file, JSON file, and analyzing data. So if time permits, I'll go with the cleaning the data, but if it doesn't, no worries. Next week, I will continue with the cleaning of the data and then with matplotlib, like in plots, visualizations, graphical representation of the data or the outputs that we'll cover. And later on, we'll start with the project. So let's get deeper into the pandas. So pandas is again, I said, library. Pandas is used to analyze the data. So what is actually pandas? If we talk about the pandas introduction and what is pandas, pandas is a Python library used for working with the data sets, exclusively data sets. So it has a function for analyzing, cleaning, exploring, and manipulating data. The name Pandas has a reference to both panel data and Python data analysis, which was created by Wes McKinney in 2008. Okay, so he's the one who brought in these concepts. So what we're trying to learn is analyzing the data, cleaning, exploring, and manipulating. So why do we use Pandas? That's one of the question. Pandas allows us to analyze big data, like in Hadoop, like in Spark and Scala, those tools which we use, like in big data, and make conclusions based on statistical theories. So Pandas can clean messy data sets and make them readable and relevant, right? Relevant data is very important in data science. Yes, that's a important thing. If you have a large amount of data and if the data is not clean, so there will be discrepancies. If you try to find out, okay, for example, like how many people are male and female, if you want to judge, if there are 100 in an Excel sheet, and if you have the gender column male and female, and out of 100, if only 90 people have got the gender column and remaining 10 we don't have the gender column, then it will be difficult to generalize whether the person is a male or female just based on the name. So we need to make sure the data is clean, and if not clean, we try to clean the data, filter out the unwanted data, and then show to the client the realistic values, and make sure that okay, we tell them that these are all the cleaned elements or the data which is already clean, and we can also tell them the total number of rows clean, total number of rows and total number of clean data, and total number of data where we have the nulls or like an no data at all. Just the example, I'll get into deeper sections of Pandas. So the same thing what we have printed here. Okay, what can Pandas do? Pandas gives you answer about the data. That's what I said. Is there a correlation between two or more columns? What is the average value? What is the minimum value? What is the max value? Right? So Pandas are also able to delete rows that are not relevant. As I said, if the data is not relevant, just delete the rows if required, uh, or contains wrong values like empty or nulls. So this is what I was trying to say. So this is called cleaning the data. So as I said, if there are 100 rows and 100 people's names, and if the gender columns we have like in male and female for only for 90 rows, and we remaining 10 on we don't have any values at all, then we call as the empty. The gender column is empty. So we'll come to the some example also. So I can give some more examples when we run through the code. So one more thing which you need to learn is Pandas. One more thing is since it's a library, right? So we need to make sure we have Pandas before we start to implement import Pandas simply. So just with Numpy also, as I said, you need to install Numpy, right? So before using it, same case, installation of Pandas. If you have Python and pip already been installed on system, then installation of Pandas is very easy. That means we need to make sure that Python does contains Pandas. So that means Pandas has been installed. So if you want to install Pandas, there is a command called pip install Pandas. Installation is used with this command pip install Pandas. As I checked, provided details earlier, right? You need to type in CMD command prompt, and make sure you try to get into this section pip install Pandas. So it will try to see, okay, collecting the data, downloading, and installing. So it will make sure that we have the Pandas. So we have to, this is a command pip install Pandas. So to enter into this command prompt, type in CMD, right? CMD, it will give this command prompt. So you get the black and white screen command window. Then type in pip install Pandas, and it will download the Pandas, and it will collect the relevant libraries, and it will install. And That's what. And just in case if it is already there, it will say, oh, it's already there. If the command does fail, then use Python distribution that already has Python installed, like Anaconda, whatever I'm trying to show right now, right? So currently I'm using Anaconda Navigator, like instead of Google Colab. So I've installed Anaconda, and within Anaconda, I picked up like this Jupyter notebook and saying launch. So which you have learned in the first class, like and how to install Anaconda software and how to start with the Jupyter notebook or launch. So once I use launch, then I get this Jupyter notebook, and I can start creating the notebooks of Python, right? So mostly it will be like a pre-install, just in case if it doesn't work, if your commands doesn't work, you need to install pandas. So so that's what we use, a command like an import pandas if it's already been installed. So we just import it, and once pandas is installed, once pandas is installed, import it in your application by adding the import keyword, import pandas. So that is what we are trying to do here. The very first line we have to say import pandas. Initially, with this thing with Numpy, it says we import Numpy. We used to type in, but we used to use the alias name as np, so that import Numpy as np. Then we have to represent np dot. Same case, the pandas also. We use the same concept. I will give you the examples as a PD, just like Numpy as np, pandas PD. So here what we are trying to do here is we're giving a simple example. Okay, we're giving a simple example. Now pandas is important, ready to use example. So we have to say import pandas, and I'm giving the data set here, right? So here the data set, you don't need to get confused. Whatever the data, I'm pushing it over here. Okay, so let me say. So I'm giving the data in this format, like my data set, cars, and also BMW, Volvo, Ford, and passing, and 372. So it's like I have the data. If you look at this data, my data set, and when I'm saying is my where equals to pandas data frame. So it's like it will be treating as a data frame. We call as a DF. So the command is my where equals to pandas data frame, my data set. So whatever the data set here is, you're defining here is when you print my where. Okay. So what it is trying to do here is, so yeah, this one. So it is going to assign into like in rows and columns. So 0, 1, 2, and defining as cars and passings, and BMW, Volvo, Ford we got in this column, and 372 in this column, right? So it's arranging by itself. Why? Because it has a capability to arrange. So let's see in depth, like pandas as PD. Pandas is usually imported under the PD alias. So just like for NumPy, we are using alias name as PD. So in Python, alias are an alternative name for referring to the same thing. So create an alias with the as keyword while importing, like this thing, import pandas as PD. Okay, pandas as. So with the as keyword. So this is what we are trying to say. So now the pandas package can be referred as a PD instead of pandas. So each time we can't say pandas, 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 so rather than we say PD dot data frame. So the same case, import pandas as PD, right? Then we're giving the same data set over here, whatever given here. But instead of pandas, say here we said pandas dot data frame, right? So here we are trying to say is PD dot data frame, same my data set, and we are when we run it, we get the same thing. The only difference is we are using as PD, since we are saying import pandas as PD, and we didn't mention the as PD over here. So import pandas and pandas.pd. So that's what the process to utilize these pandas. So let's get into deeper. Checking the pandas version. The version string is stored under underscore version underscore attribute. Example, when you say import pandas as PD, but I want to know what version of pandas I'm using it. So it says 1.0.5. So print PD dot underscore version underscore. So that's I think the double underscore is like an say this double underscore version double underscore. It gives the version number of the pandas. So that's what for the versioning. And today we'll learn about series. So we, as I said earlier, we learn this series, Panda series today, and also we will learn data frames. Okay, so cleaning part we will leave it in this next bit. But let's quickly jump into the section. Okay, what is series? So when I say what is a series, a Panda series is like a column in a table. It's very simple. Let me open the Excel sheet. Okay, let me open the Excel sheet. Let me pull it out. Okay, data. So if you look at my screen, whatever you see over here is data.csv, right? Data.csv. So it is a CSV file. Within Excel, we can have multiple files, right? When I say save or save as or something like that, and when I say browse. So if you look for the formats, so we got different formats of Excel. Like in Excel, we can store in .xls, like .xlsem and simple format CSV, right? DOS format, machine DOS format, and then PDF and which are the format. So here we are talking about CSV, the comma delimited ones. And when I see the values inside it, okay. So what are the values inside it? Here is we got duration, we got pulse, we got max pulse and calories. So these are all the values. So if I want to read this data using this pandas data frame, so how we're going to read and what are the different methods which we'll learn over here now. So that's the next step. But in reality, here we are trying to learn the columns, especially here we're just giving the simple values. Then we'll go to some examples of files in this case. I think, yeah. Let's go a little bit deeper. Yeah, in this case, we're talking about files and all to read the CSV and all. But before getting into the CSV, jumping into the CSV files, we'll give some simple examples like we got data and how we're going to read the data. So let's see. So what is a series, right? So here what we're giving is a equals to 172. We are providing the values and we'll say my var equals to pd dot series a. So what it is trying to do here is we give the indexes 0, 1, 2, 3, 4, 5, 6, and 1 is assigned to index 0, 7 is assigned to index 1, 2 is assigned to index 2. So those are all the default things which it will assign. And also it's say when we say my var, it is picking up the values 172 and it is showing the index values and also the type. D type means the data type. Data type is integer. That too, there's integer 64. So let's use one more thing. So labels. So here, as I said here, so here my var, so index 0 is 1, right? When I want to know the value of the index 0, what value, here we know that 1, we are able to read. Okay, 0th index is 1. Same thing, what we're trying to do is print my var of 0. Here I didn't say give the index value of 0 or 1 or 2. I did ask here to print all the values, but here I'm trying to say, okay, you just give the index of 0, index value. So what we're trying to do is nothing else is specified. The values are labeled with their index numbers. Okay, first value has index 0, second has index 1, etc. So this label can be used to access specified value. So in future, if you're trying to run a project and if you're working on a project, okay, so there will be a need as situation where you need to read it a file like in column name or the value name straight away. You don't need to read all the values. So in that case, so return the first value of the series. In this case, what we're trying to do, my var of 0, that means 0th index value is 1. Just in case if I say So 1, what is the value in index value 1? So let's say, see here 1, 7, and 2, right? So my where 1 is 7. So we got value 7. So we are defining the index values only here. We're not saying, okay, value name or like an what value it has. So when I say print my where of 0, it is giving up the index values corresponding value. So these are all the index values and these are all corresponding values. So that's what we're trying to define as the labels. So creating the labels, how we are going to create the labels instead of this 0, 1, 2, 0, 1, 2, we can use some labels also. Creating labels. There will be a certain situation where you have the data and there are no column headers, right? Right? How we're going to utilize it, right? So in that case, this is one of the good example. Import pandas as PD. Here I'm saying 172, and then I say my where equals to PD dot series, right? A comma index equals to X, Y, Z. So what it is trying to say is index X is 1, index Y is 7. So index Z equals to 2. So we are defining the indexes to the corresponding values. So when we run this line, so what it is trying to say is X is 1, Y equals to 7, and Z equals to 2. So this is one of the example where we can learn saying that, okay, we can assign the indexes, our own indexes, to the corresponding values. So that tomorrow, if I want to print the index value of Z index 1, so 2 will be displayed, right? The same case, what we are saying, my aware of something like that. So we can still do it just in case if I say here, if I'm saying yes, my where instead of let's say X, I think it should print. Let's see. Yeah. The type. Okay, this is an error. So this is not the way which we can give. Why? Because it picks up like an 0, 1, 2, 3, right? So let's remove this. We'll find out the other methods. Okay, uh, to use this way. Okay, let me use this current method only. So here, my where. So let me give the same method like in indexes of 0. Okay, let me run this. Yeah, so we can still use this same old school example, whatever we have learned in the above example, rather than using this XYZ, we have assigned it. But just in case if you want to pick the value of index 1, yeah, 7. So I'm just trying to see that if you want to read the values directly. Yeah, here it is treated. Yes, here it's giving. So I think I was supposed to use the double quote. That's what the mistake I've done. So in the earlier example, so I've given the single quote. So let me remove this. Yeah, let me remove this. So in general, if I want to assign the values XYZ, we got the XYZ values 172 and the data type is integer. And when you have created labels, you can access an item by referring to the label. Example, so what I'm trying to do is return the value of the Y. So earlier I've given only single quote. So that uh, created the problem. And if I say single quote and run it, it got it. Okay, might be I've used in a different format or something. Okay, something went wrong. Okay, but I think so. Even at a single quote, it's giving you okay. Print my where of brackets Y. So Y will be 7. So that's good. If I use double quote as well, it is picking up. Yes, both the ways. The double quote also it's giving up the value 7. Why? Because for the index Y, 7 has been assigned. So the same case. So when you have created your own labels, you can access the elements also for the corresponding indexes. So that's what the option. And one more thing, what you have learned in the beginning of the sessions, Python, we talk about the key value pairs. Like we can assign the a key and we can also retrieve the value correspondingly. So here the key value objects as series. So you can also use a key value object like a dictionary. If you guys remember the dictionary in the beginning. So dictionary is nothing but key value space. Like if you got an employee number and if you got an employee name, number and the name. So here also the same case, like a day 1, 420, day 2, 380, day 3, 390. So what we are trying to do is create a simple Panda series from a dictionary. Our example is we are trying to create a Panda series from a dictionary. So here we have a dictionary, and what we are trying to do, import pandas as PD, calories equals to day 1, 420, day 2, 380, day 3, 390. So my var equals to PD dot series of calories. So here, when you say print my var, so it is picking up the values day 1, 420, day 2, 380, day 3, 390, and data type will be integer. Why? Because these values of integer values, these values. Okay. So let's pick up one more example. What we are trying to do, difference between these two, creating a series using only data from day 1 and day 2. Yeah. So that is what it's trying to do. So what we have done here is we are given by day 1 and day 2 and day 3. In this case, but here we're giving the same example, day 1, day 2, day 3. But here indexes we are giving only for 2. It's up to my wish. So you create the indexes and then print the indexes. So if you look at the differences, just be carefully look at this example. So what I'm doing over here is, okay, so look at this, import pandas as PD, and here the same case, import pandas as PD, pandas as PD, and the calorie is also the same format which we have provided the dictionary, right? But look at the next line, my var equals to PD dot series, calories, comma, index equals to day 1, day 2. But what we have given here is my var equals to PD dot series calories. So the difference in between these two lines is we are not mentioning how many indexes. So Python itself is picking up the indexes and it is assigning the values. But here we are trying to provide like an only for index day 1 and day 2. So that's the reason day 1 it is picking up as 420, day 2 as 380, day 3 he is ignoring. Why? Because we're given this condition, day index equals to. So we can have this some certain limitations, only these two lines which we need to go through it, or like we want all the elements. So that's what we're trying to say, day 1, day 2, day 3. So which we're trying to say. And also here we are also giving mentioning as index equals to day 1 and day 2. So this is what, let me pause for a second to have some breathing space. Recording. So that's what the difference is. So we are able to define the indexes to the set number of elements only, or else we can leave it to Python itself, let it define the indexes automatically and print the values. So this is what the only difference is, creating a series using only data from day 1 and day 2, something like that. So that's what the case is. Okay. Resume the recording. So we've learned those two things, and let's talk about data frames. We talked about the series, we talked about the data frames. So what does data frames means? Okay, data frames means, so here the data sets in pandas are usually multi-dimensional tables called data frames. Okay, data sets in pandas are usually multi-dimensional tables called data frames. Series is like columns and data frame is a whole table. So this is only the difference. Okay. So how does series different from the data frames? Means series is like column. Okay. And data frame is a whole table. So here what we're trying to do is, example, create a data frame from two series. Okay. So we got this thing over here. We got data equals to calories and also duration. Okay, like I want to burn these calories in certain time duration. In 50 minutes, I want to burn 420 calories, or like in 45 minutes, I want to burn 390 calories. So corresponding. So what we need to do at the first stage is load the data into the data frame objects. So that is this is totally little bit new over here. We talked about PD pandas data frame, but here we're talking about so we're loading. So what we're trying to do here is df equals to pd dot data frame of data and print. So what we're trying to do here is you need to look for the data. What's the data and how the data been assigned. So we got calories and duration which have been assigned. And when we said first of all loading the data, so this step df equals to pd dot data frame data. So this is what the step, it is loading the data into the data frame. It will be like a temporary memory. And when we print the data, print df means data frame. So what is happening is we're getting the rows. These are the rows, right? And they are the columns, calories and the duration. So we can have multiple rows, multiple columns in an Excel sheet. As I showed in the earlier example, if I want to look at this one example, this is CSV file. As I said, we got duration, pulse, mac pulse, calories, and 4 columns. And if you look at the number of rows, if I scroll down, we got nearly about 170 rows. We got nearly 170 rows here, and we got 4 columns, right? Rows and columns. So in this case, so at the first instance is how to load the data, we need to know. If I want to write something into an Excel file, at least first thing I want to know that how to load it, right? Then next time I would say, okay, please load the data into an Excel file. Then it will load the data into Excel file. So here, the first step is df equals to pd dot data frame of data. So when you print it, it's not necessarily that we need to print it, but to see what the content is, we are printing it here, right? Even though if you give the comment, we won't get an error message. But the thing is that it won't print anything. We don't know what's happening. So that's the reason we want to print the data frame. So here it is giving the calories and the duration. So the next step, what we're trying to do here is locate the rows. So let's look at one example. See, as you know, Python is giving the indexes, right? So rather what we call as a locate the rows. As you can see from the results above, the data frame is like a table, right? So data frame is like a table with rows and columns. So that is what we're talking about, the DF. We got rows, 3 rows and 2 columns, right? So with the indexes, we can say 3, but usually calories and duration, the 2 columns and 3 rows. So as you can see from the above results, the data frame is like a table with rows and columns. Pandas uses the lock attribute to return one or more specified rows. Lock. See, if you look for LOC means location. So what we're trying to do here is a simple example, return row 0, refer to the row index. So what we're trying to do, if I want to print this value, 420, the calories value, so 0th index, right? So print df dot log 0. That's what I'm trying to utilize over here, right? So it's giving 420. And with this whole, or like an, if I look for the row as a row, so calories equals to 420, duration equals to 15. So what we have printed over here is return row 0. We're talking about return the whole row. So the row will be here to here will be a row, right? So here to here is a row. Like when I say return row 0, refer to the row indexes, 0th index. So print df dot log 0. That means it is printing calories 420, duration 50, and name equals to 0. Why? Because we are not giving anything, and d type equals to integer. We'll come to this point also, right? But in this case, we talk about 0th index rows, like an row 0, we're printing it. So for that, so let's pick up one more example. So this example returns a Panda series. So how come you say that, okay, this is Panda series and that is a Pandas data frame? So we're talking about df.log0. We got the elements. So return row 0 and return 1. Use a list of indexes. So what I'm trying to do here is print df.log 0 comma 1. When I say 0 comma 1, is see what all I got. 0th row, I got the elements from 0th row, and also I got the element from the one. That means the following one also. So you got how many? We got three actually, three rows, but we got only two. Why? Because I mentioned 0 comma 1 only. That means 0th index 1, and also like in 0th row, and also first row. So note, when using these brackets, the results in the pandas, the result is in the pandas data frame, right? So see here, we're given this thing bracket 0 comma 1. So that's what the difference. So here, what is the difference here? We are talking about the only the brackets for the 0. Here we're giving as 0 comma 1. Look at, we got double braces over here, uh, closing and opening, right? So lock 0 comma 1, that's the reason we got 2. So that's the reason I said when using this type of brackets, the results is in the pandas data frame. So let's talk about the indexes. Again, let's go back one step back. Named indexes. So with the index arguments, you can name your own indexes, as we have talked about this example earlier also, but little more details, like example, add a list of names to give each row a name. So like an import pandas as PD, right? So we're defining the data over here, like data equals to calories and the duration. And when you try to define df equals to pd dot data frame, data index of day 1, day 2, day 3. So here, instead of having 0, 1, 2 like this, 0, 1, 2, which Python is defining the indexes. So here, what I'm trying to do is say day 1, day 2, day 3. Okay. When I run this, you see that you got day 1 is a calories 420, day 1 duration 50, same thing day 2 and day 3. So we can define whatever like an XYZ also, and then I'm saying print df, right? So there's one more thing, like a locate named indexes, the same thing which we have learned earlier. Use the named index in the lock attribute to return the specified rows. Like I want to return the day 2 only. So print df dot lock day 2. So when I run this, okay, so this one, day 2, we are getting the values 380 and 420. Calories 380, duration 420. Name equals to day 2. See this? This is what I was trying to say. Name equals to day 2. Why? Because this is a name for this row. Row 0, day 1 is a name. Row 1, day 2 is a name. And row 2, day 3 is a name. And the data type is integer, like in 380, 390, 50, 40, 45, they are the integer type. So here in the earlier case, when we got like an I think here, see, name equals to 0 in the sense 0 is nothing but so this 0 is nothing but the name it is defining. So that's the reason the 0 is nothing but the name. 0 is a name, 1 is a name, and 2 is a name, right? The same thing over here. So we're defining for this row. For this row, we're defining as day 1. For this row, we're defining as day 2. For this row, we're defining the name as day 3. So that's what. So is a named indexes. So we're defining a name to an index. So instead of like an automated ones, which Python gives, we can give our own index names also. So there will be a need tomorrow if I want to read some columns in a row in a CSV file. So that's what the example I'm going to show it now. So far, you guys have learned about, okay, Panda series and data frame. So now what I'm going to do here is there is a need to understand. Let me show. So here, what I'm trying to say here is we got Excel file data.csv. So what I'm trying to do, I've shared this data.csv in the group also. So with this data.csv, I got certain data, rows and columns. So now I want to read the information from the CSV file, Excel CSV file. So how I'm going to do that? So if I want to read it, so what I'm trying to do here is first of all, how to read, load files into a data frame. If your data sets are stored in a file, Pandas can load them into a data frame. Example, load a comma separated file CSV into a data frame. So this is a simple example. It's a 3 lines, simple 3 lines code. You don't have to worry. One is saying that import pandas.pd, that is to import the libraries. And the next step we are trying to do is df equals to pd.read csv. When I say pd.read csv means, so I'm talking about CSV file and says read underscore CSV is the command. And what is the name of the file? Data.csv. So wherever you're using this Python file, you need to have the CSV file in the same location. So that is what I'm having the same thing. I got the Python file over here, and I also have the CSV file over here. So that is the reason it is able to pick up the data from the CSV file. And to simplify this, what I'm trying to do here is I'm saying as end rows equals to 5, means I'm saying that please do not bring all the data into this what is say Python notebook. I will show you both the examples. So df equals to pd.read csv. So this is the name of the file name, data.csv, and end rows equals to only print 5 rows. When I say print df, the data frame. So what it is doing is here is giving only the five rows. Just in case, what I'm going to do is I'm going to copy the same line and push it back over here. And what I will do is I will comment this. And here I'm going to say only, so this line, if you look at this line carefully, df equals to pd.read underscore csv data.csv. So what will happen when I run this? See, I get all these things like in 0, 1, 2, 3, and all 164, 165, 167, and 167. So see, total 169 rows with 4 columns. How do I know? So if I read back or like and look back to the CSV, the first one got the titles, right? So let me give this thing parallelly. So here says we got 4 columns. Column 1, duration. Column 2, pulse. Column 3, max pulse. Column 4 is calories. 4 columns. And rows, 169 rows. Why? Because the first row is the title one. We shouldn't consider that. And from number 2 to number 169. So the data has been present between these two things only. Like in column 2 to, even though it says 170, the first row is the title. So it's saying that 160 rows and 4 columns. So we shouldn't say 170. Why? Because row 1 is the header. Row 1 is a header. So that's the reason it's saying total 169. So if I comment this back, okay, I don't want to see all the rows. If there are like 1 million rows, it will print all these things uh, in this format, and it will show. Rather, I would say that just print the rows, only 5 rows. Then it's simple. df equals to pd.read underscore csv data.csv end rows equals to 5. So fairly simple and neat and clean. The same thing, let's say Pandas Read says it's also the same thing, but I'm giving another way, slightly different command. Okay, Pandas Read CSV means read the CSV files. A simple way to store big data sets is to use CSV files, like in comma separated files. So whatever CSV means comma separated files, like an Excel CSV files. So CSV files contains plain text and is a well-known format that can be read by everyone, including pandas. So in our example, So in our examples, we'll be using a CSV file called data.csv. That is what I was trying to show, like in data.csv, right? So data.csv, I got a file name. So import pandas as PD, that's the same thing, but df equals to pd.read csv and file name and rows only with 5. But this time I'm saying print df dot toString. Okay. So look at this difference here. I'm saying as print df. Okay. I'm giving the same thing. And here it says print df dot toString. So any idea, guys? What I'm trying to do here, Mr. Ryan? So here it says Pandas Read CSV we're giving, right? Here also we're saying is Pandas has a loading the data into the data frame. So if you look at this example and just trying to say, let's see toString, what it is trying to say here. Okay. Okay, that's okay. Okay, so what I'm trying to say is why there is a difference over here, which we're trying to say pandas dff you're trying to say, and here we are giving like an uh, uh, a print df, and here we're saying print df dot toString. Yeah. Yeah. Yeah, I got it. Yeah, yeah. Tell me. Data types, right? Yeah, yeah, yeah. Yes. Yeah, yeah. str object is not defined. Yes, yes, yes. That is what I'm trying to say. Yeah. So, yeah. So, okay, let's get back to the example. Yeah, thanks, Han. So, what I'm trying to say here is, so in this example, okay, so whatever we have run over here is, so import pandas as PD, df equals to p dot read csv. Okay, so here when I say pddf, okay, so it's just printing the data frame, and it's also when I say print df dot dtypes, it's trying to print the what is the type of data it has contains, like duration is integer, pulse is integer, max pulse is integer, and calories it's in the float format. So the same case which we are trying to run here, but this time using Pandas series to string. So function render the string representation of the series, like so here what I'm trying to say here is like an headers, like an true, or like an index equals to true, like an, so it's like conversions, like an is there any like a toString is pandas, like a pandas data frame toString function renders data frame to a console friendly tabular output, so writes all columns as default. So it is like an conversion. Okay, it's like in conversion. So here it's trying to convert and store it accordingly, right? So the same thing which we're trying to read here. Okay, so here one more thing. Yeah, yeah, note. So use toString to print the entire data frame, right? So you, yeah. Yeah. Yeah, that there was a gap. So here we are using toString. Here whatever we are using is toString to print the entire conversion, right? So whatever they're talking about internet, Panda series toString function renders a string representation of the series. Yeah. So this is also the yes, yes, yes. Yes, yes, yes. Yeah. So here, this is also the line which we need to add to the audience, saying that Panda series, in this case, when you say toString, so function renders a string representation of the series, right? So by default, when you print a data frame, so one more thing what they're saying is by default, when you print a data frame, you will only get the first 5 rows and the last 5 rows. So this is what we're trying to say. So even though if I remove, if I have this and if I remove this thing, like an n rows equals to 5, and when I run it, see if you look at this thing, data, see the massive amount of data you're getting, right? So it's entire thing, like it says use toString to print the entire data frame. Actually, this is what it was supposed to do. Since I added that n rows equals to 5, that was created the confusion. So this is what actually it is trying to do. So input pandas as PD, df equals to pd.read csv, data.csv, and when I say print df.toString, so here, if you look at all the values, like, and we got 4 columns and starting with index 0, and you got all 169. If I scroll down, okay. So 168 means starting value is 0, right? So we got all the data inside the data frame. So that is what it's trying to do. And yeah, to avoid the confusion, to bring only 5, I'm trying to add as n rows, but I'll remove this. So it will remove the confusion. Okay. So let us go back to these lines. So use toString to print the entire data frame. But one more thing is that when I say in Pandas series, toString function renders the string representation of the series. So, so it's just trying to represent in the string format. That's what it's trying to convert and show it to us. But by default, when you print the data frames, you will only get the first 5 rows and the last 5 rows. So let us run in this format. I'm not using this command like toString, df.toString this time. What I'm trying to do here is, let me, okay, I've just scrolled down a little bit down. Okay, so this time what I'm trying to do is print a reduced sample. So here df equals to pd.csv and saying print df. So if you look at this, it's as I told, first 5 rows and the last 5 rows, right? By default, when you print a data frame, you will only get first 5 rows and the last 5 rows. So when you say print df, these are all the first 5 rows and there are the last 5 rows. You can count also, right? But it will say there are 169 rows and 4 columns. So the CSV file. So I'm taking little bit more time, just like in 5 minutes I will take, and not more than that. And then we'll end the session for today. And I think we have extended 13 minutes, but we'll extend another 5 minutes and we'll end it. So for example, the JSON file. So what is this JSON file? JSON file is again the another format of data when I say JSON. So JSON is an open-ended format file. And so what does JSON stands for? JSON stands for JavaScript Object Notation. Okay. So let me give this thing into this section. Okay. So this is not it's not required in our case, but to clear the confusion, what is JSON? JSON is nothing but here. JSON stands for JavaScript Object Notation File, JSON, and is a lightweighted format for storing and transporting data. JSON is often used when data is sent from a server to a web page. So if you want to send the information, and that too with which can consume the less amount of space, so we convert the files into JSON and transport accordingly. Is often used like in sending from a one server to a web page. So that's what. So what we're trying to do here, big data sets are often stored and extracted as JSON. Because when you talk about big data, you need to, we're talking about millions of rows, and that will consume a lot of space. To get rid of the space and to make sure we don't lose the data, and we need all the data, but it should consume only less amount of space. So how are we going to achieve it? In that case, convert to JSON file and then send it across. So that's the easiest way. So JSON is a plain text but has a format of an object, and is well known in the world of programming, including pandas. Okay. So in our example, we'll be using JSON file called data.json. So there is one more file which I'm going to use, like a data.json file. This is one more file, data.json. So JSON file I did shared in that group also. So import pandas as PD, df equals to pd dot read underscore JSON and the file name. So this file should reside in the same folder. And this time I want to say print df dot to string. So this time, if you look at this, the same thing you'll be getting, but this data is in the JSON format instead of the CSV. The same, all the rows 168, but in the JSON format. Only the difference between the sizing. Okay, if we look at the CSV file and the JSON, but this will be like in lightweight. Okay, so data.csv and data.json. Okay, but in the for the Python point of view, it will be the lightweight. That's what I feel. Format to send it across from server to web page. Okay, so here the command is read underscore JSON to read the data in the JSON. For Excel, read underscore CSV, and file name should be underscore file name dot CSV. Here, what we need to have is file name dot JSON, the extension. So this is what we're trying to read. And let's pick up just 2-3 examples. But what I will do is I'll push the analysis, pandas analysis into the next class. Like here, I will talk about this one into next class. Analysis, pandas analyzing the data and also cleaning. I'll push it to week 10. So next week. And next week, most we will finish up the pandas analysis and also the cleaning. So however, I will share the files. So it's not the difficult thing. I will share this and just trying to, if someone is trying to analyze the data, they can use these commands. The same thing like a read only the top 10 lines we call as a head 0, head 10 to read the top 10 rows. And the same case, we got tail also, but we're giving the rows. So, and also how many, if you want to know the total information about the file, it's giving the information and also the range and all. So it's those we can talk about in the next session, week 10. But I'll give one example and then we'll end the session. So here, example, load a Python directory into a data frame. Sorry, dictionary. Load a Python dictionary into a data frame. So here, import pandas as PD. So when you say load a Python dictionary into data frame, so here this is one of the set like a duration. This is one of the set like in pulse. This is one of the sets like in max pulse, and this is like in calories. So I have got a whole set of a dictionary, right? So the whole dictionary is being set and is being assigned to data. Load the Python dictionary into data frame. I'm saying data equals to the whole dictionary I've assigned. And then what I'm saying, df equals to pd.data frame of data. See if it is data and this been assigned as over here data. So what is the difference when we say dictionary? What is actually a dictionary? Is dictionary means like an key value pairs. 0 is 60, 1 is 60, 2 is 60, 3 equals to 45, 4 is 45, and 5 is 60. So is a key and the value. It's a key and a value. The key value pairs which we are assigning, and the data is for the duration, and we're talking about pulse, we got max pulse and calories. So once you run it, what is happening is it's going to show it in a tabular format with rows and columns. So this is what the advantage. You, even though if you have defined like in key value pairs of information, dictionary values, key value pairs, and that means we are passing the dictionary into the data frame. How do you say this data frame means? He says like, see here, df equals to pd.data frame with this command, and we are printing it. So it's converting like in rows and columns. So that is what we got over here. And so simply we can say that we have loaded the dictionary into a data frame and we are printing the data frame. So that's an example. So in the next session, we'll talk about the analyzing the data frame, and also, as I said, we also need to talk about the cleaning, data cleaning. So yeah, we'll learn about the cleaning as well. There is one more thing which we need to learn is plotting, but plotting we'll be learning about uh, uh, plotting. So plotting we'll learn in Matplotlib. Okay. So plotting is nothing but, again, we'll talk about Matplotlib. So Matplotlib is, again, we talk about this graphical representation and everything. So once you have learned these things, it won't take long. Data frames like in 15 minutes, analyzing data frames and data cleaning again 15 minutes. And plotting and all, we can go with 30 minutes. That's what we'll be doing it. Other than that, it should be fine. So mostly next week, once we finish off the Matplotlib and data cleaning and data frames, analyzing the data frames, then we can start off with this following week with the project. We'll let you know what the project is. A simple project, we'll pick it up, and you guys can come back with a solution, what you have learned so far with the past 9 to 10 weeks. Then that will be a good exercise. You can keep posting the questions also. It won't be an issue for me. I can answer it. Okay.